Satya Nadella, the CEO of Microsoft, recently said this on a podcast.
And I feel like there's a new inbox that's going to get created, which is my millions of agents that I'm working with will have to invoke some exceptions to me, notifications to me, ask for instructions.
An inbox for agents, eh? Well, challenge accepted, Mr. Nadella, as I have gone ahead and built this. Agent Inbox is a platform that lets you construct agents and then assign them tasks and then have them work together in a coordinated fashion in the background. The agents can talk to each other, perform long-running multi-step tasks, use tools, and then report back to you with the answer. They are equipped with a bunch of powerful abilities, such as the ability to schedule subtasks to be run at a future date. You can even get them to email you when they've finished their work. So in this video, I'm going to take you through how I built this app from scratch in just a few short days. And then we're going to take a deep dive into some of the key parts of the code so you can get a better sense of how agentic apps like this can be built in record time on Convex. And stick around to the end as we're going to have a bit of fun with my suite of agents and see how they handle a complex task that may or may not have evil intentions. Okay, so demo time. So this is Agent Inbox. It's got this lovely landing page on the front of it with this nice logo. Thank you, AI. And I've got this very kind of simple auth section here, which is built using Convex auth, which makes this kind of thing pretty easy to do. And I just slapped a nice front end on it. I could log on with email if I wanted to, but let's just keep it simple for now and sign in with GitHub. As I've already got an account, it just logs straight in. So this is the application itself. So on the left-hand side, we've got our sidebar with our little account information and a sign up button. And then we've got two tabs here. We've got conversations or agents. So let's quickly look at agents first. So the idea with this app is you have multiple different agents with different specialities, and then they're going to talk together within a conversation and hopefully do your bidding. So on the left-hand side here, we can click on one of these agents and we see like the social spark, for example. And it has an about and a personality. And the about and the personality combined together basically equal the prompt that we'll be giving to the agent as its system prompt. We can potentially shuffle the avatar if we want. Not sure why you'd want to, but you could rename it, obviously. And also has the tool section down here. Now, at the moment, there is only 3 tools that you can choose from, but built into it, there is actually a lot more tools. So some of them are just hidden and every agent gets them. That's why I've hidden them. So moving on to conversations. On the left-hand side, we have the list of conversations. I see I've got a couple of other conversations that I've had before. But let's just start a new one. So clicking new conversation, you can see it's just given the title new conversation. We can go up here and change the name if we want or delete it. I won't change it for now for reasons you'll see in a minute. And then on the top right-hand side, we have the conversation participants, and we can add other participants manually if we want, but as you'll see in a minute, it's not necessary. So let's tell our army of agents to do something. So please create a funny tweet about cats, because who doesn't want funny tweets about cats? Okay, so immediately we'll see that the system triage agent jumps into the conversation. So it does this because we didn't explicitly reference a agent. So the system triage agent is one that's built into every conversation, and it will immediately add itself to the conversation. And then it has used the tool listing agents to list my agents that I have access to. And it's detected that Social Spark is probably the one that would be best to handle this. So it's told the Social Spark, could you help write it? So because it referenced it, the Social Spark agent jumps into the conversation. And the first thing it does is update the title because it wanted to. And then it came up with a tweet. So that's cool. That's exactly what we wanted it to do. So we can follow up by clicking this reply button here and say something like, please do one about dogs. And it will then do one about dogs. And it obviously has reference to the previous messages in the conversation, so it knows what we're talking about here. Okay, so let's do something a little bit more complicated now. Let's see if we can ask so we can hop in our military expert. Let's say, please, can you do some research on what the best tanks are in 2025, then ask another agent to write a tweet about it. And let's see what it does here. So the military expert has jumped in, and now it's using its web search tool to search for the best tanks in 2025. So let's have a look. And now it's thinking, okay, so it's found some tanks. That's great. Oh, and now it's asking the social spark. I think we've noticed a bug here because it got referenced twice, so it called itself twice. But no worries, because it did the job. It calls the tweet the first time. It's saying the tanks are the mightiest tanks in the battlefield. Check out the top contenders: the M1A2 Abrams and blah 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 blah. And it says it looks like I've already crafted this. So it's smart enough to realize that it got called twice, so it didn't do it twice. So that's great. So I think that worked quite well. Just inside of baseball, I ran this demo a few times, and it didn't do this every single time. So I'm quite happy with this. We'll just leave it there, I think. Well, I will just mention a little bit here then before we jump into the code, that one of the big difficulties I had with this is just subtly tweaking the instructions can have like a really big difference. And it's just, I don't know whether this is just common with building agentic apps, but getting that prompt just right is tricky, and it's half the battle. And I think probably having some sort of AI evals would help me get a bit more reliability into the expected output from these agents. So with a semi-successful demo, I think now's the time to jump into the code and have a look how some of this was built. Okay, so the code base is a pretty standard Vite React app, so hopefully familiar to most of you out there. At the top level, we have our app component. Well, actually, we have the main, and then which has the Convex provider. And then we have the app component, which has a few other providers inside there. The first one being the root provider. I think we'll just go a little quick tangent here. So not many people might be familiar that with the library typeroot, it's a really cool library that doesn't get a lot of attention, but it allows you to, in a very type-safe way, define your roots in your application. And I use it for all my projects. I think it's great. When it comes to, you define your roots in a roots TS file like this, and then you provide a provider, and then inside your code, you can basically just do like if statements effectively. If the root name is equal to this, then it narrows the type down. So we have the parameters here. So we guaranteed, to have the parameters in it from the root that was navigated to, which I think is a really nice way of doing things. So, going back up to the app level, we have a query cache provider, which makes it just a little bit nicer when we're navigating between pages. Things load a bit quicker because they're cached between loads. And then we have our toaster from ShadCN. Okay, so then we have the two sections here. We have it authenticated and unauthenticated. So the unauthenticated content I won't talk too much about, but it's basically just that sign-in page. We're using, the standard sort of React, Convex React auth stuff. So I won't bother going into that too much. Let's have a look in the authenticated content. So this is what you would expect as well. We have some React components. We have a sidebar, and then we have like the chat area, and then we have like the agent profile. These are like basically different pages. And then the agent profile is what you'd expect, just a bunch of stuff for CRUD stuff for updating, showing, displaying agent profile. And then on the chat area is the bulk of the code, where we have our chat messages being shown here. We have our thinking indicator, and then we have, our, is it on here? Yeah, our chat input. So this is the main place where you put your input in and send it to the server. So talking about that, let's just go through what happens when you press enter in the input. So let me just show you what I mean. When you press enter in here, bam, what happens when we click send? Right, so we call this send message mutation, and we can just control click to go into the definition of this. So now we're inside the Convex directory. I'd like to just quickly talk about the structure of the way I like to structure my Convex folders and things. I usually like to break them down by feature, or like entity, the main entity in the application. So if we just have a look at schema, for example, this is our tables that we've defined in the application. We have conversations, agents, conversation participants, and conversation messages. So that's kind of like how I like to break down my folders generally. And we have like another one here for AI. Because it's large enough and covers the other features that I thought I would just break that one out. But within each of these folders, I then like to break them down by the kind of convex function that you find inside there. So you might have actions, internal mutations, internal queries, or queries, mutations, and actions. So that's kind of like how I like to break them down, just so it's really clear when I'm navigating through the files. So just going back to our conversation message send from me, the first thing we do inside the handler for here is I'm ensuring that this current user, the one that's currently logged in using auth, can access this conversation. So we're just making sure that one user can't access another user's conversation. And then what we do is we then call into this messages add message conversation from me function. Oh, I should just mention here as well that I have split, you'll notice that there's no actual logic within a lot of these functions. So they are effectively, the convex level here is stubs for the actual implementation, which is then held within this model file. And the reason for that is because quite often you find yourself wanting to call some shared functions between different places. So you can call a convex function from within another convex function. That causes you to have another function invocation, and it has lots of other sort of implications around it. So instead, what it's often better to do is to just create some helper functions elsewhere and then just call them from your convex functions. So in this case, we have the add message to conversation from me, which calls another helper function from the conversation participants. This is a prime example of what I was just saying about. This get my participant is probably used in a lot of different places. So it's useful to have this broken out as a separate function that we can just call from different parts of the code base. So once we have the participant in the conversation, we can then add the message to the conversation. So if we're going to here, what it's going to do is going to insert the message into our conversation messages table. It's going to update the last message time in the conversation, which is used for various things. And then it's going to do this part, which is the key part. This is where the AI magic starts to happen. So this is where we schedule a function to happen at a later date, but we're scheduling it with time 0. So what that means is that it's basically going to run immediately. So what the function is going to call is we're going to call this process message function with a message and conversation. And we have to do it this way because in Convex, mutations and queries are deterministic. That means you can't do effectful code within them. So we have to schedule another effectual thing to happen at a later date, which is what this process message is. So if we go into that, we see that it's an internal action, which means that it's internal, which means it's not accessible from the client side. Action, it means that it's going to do effectual code, which means we can call out to third-party APIs and like OpenAI and get something back. So if we dive into what the implementation of this is, let me just give us a bit more space here. So the first thing we're going to do is we're going to say we're not going to handle system messages. So in the application, there are two kinds of messages that I've got defined here. We have just normal participant messages here, which is like, either me or the agent. And then we have system messages, which is what these things are. So tool use effectively, or somebody joining the conversation is what I call a system message. So we don't want to handle those. We only want to have our code respond to code from other participants. And the first thing it's going to do is it's going to try and parse out any mentions. So a mention is just this little here where we're atting somebody. I call it a mention. So what we want to do is we want to grab those out of the message content because these things embed them using special syntax. So hello at, and then the name of the person, and then user colon or agent colon effectively is a way that we can create a mention to somebody within the code. So we can grab all those out, and if there are no references, well, what we want to do is we want to hand this over to the triage agent. So the very first thing we do is going to grab the author of the message, and we're going to pass that to this triage message function. But if we do, we'll skip over that for a second. But if we do have references, we're going to loop over each reference, and we're going to, if the reference is a kind of agent, we're going to grab the participant and then reply to that message. And I've just realized where the bug is that we saw before, where it messaged the social spark message, got messaged twice and replied twice. It's because we haven't deduplicated these references here. So it's answered the message twice. So I will have to fix that one afterwards, I think. So I could hop in and show you the triage message or the agent. Let's have a look into the agent message, because they're both kind of similar. They're both doing slightly different things. But the agent message is, so we hop in here, and the first thing it's going to do is it's going to get the agent itself and ensure that it's joined conversation. So at this point, because an agent may have been mentioned, or you might have added it, so you might have mentioned it yourself in your message, it may not be a conversation participant yet. And every agent or human that messages in a channel needs to be a participant. So that's what this is doing. It's just ensuring that they are a participant in the conversation. And then we're going to get down to the actual bulk of it. So this run agent AI generation is just like a helper wrapper that's going to update the thinking status for the agent, and then it's going to just catch any errors when we run it in a minute. So the actual bulk of the AI calling is this part here, and we're calling using this generate text. And if you've used the Vercel AI SDK before, you should be familiar with this, because that's exactly where that comes from. So we are calling generate text. We're going to use GPT-4o. I did at the beginning use GPT-4o mini, but I found for whatever reason it was not as reliable as 4o. So even though this is more expensive, I know, I'm still going to use 4o here just because I found it more reliable. So, and then we have the tools section, and then we have messages and max steps. So tools, as I mentioned before, there are there's two different kinds of tools. There's tools that a user can choose, and then there's tools that are included with every single every single agent. So the tools are defined. Here in this shared tools directory, and we have got tools like list conversation participants that we saw in the demo. We've got list agents, which allows listing of a user's agents, message another agent, noOutput web search, scheduleTask, update conversation title, send email, and blah, 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 blah. You get the idea. So the only one that's kind of like interesting to talk about here is this noOutput. Now, this is something I picked up from the Vercel AI SDK, which is an interesting one. If you want to have the agent stop responding to a message, you can get it to call, you can tell it to call this noOutput tool. And the definitions for it is here. Where is it? noOutput here. So what I showed before was the definitions for the tool, so which contains its name and description parameters. But then over here in this directory, this tools, we define what's actually going to get executed. And each tool has got an execute function, except for this noOutput tool. So this noOutput tool doesn't have one. So that means there has no function body. And so what that tells the Vercel AI SDK is to just stop executing the agent once it detects this. And I should probably just back up a second and explain what I mean by stop executing, because this wasn't something that was obvious to me when I started this, is that when you run this function from the Vercel AI SDK, generate text, what it's going to do is not going to do like a one-shot call into OpenAI. What it's actually going to do is do like multiple calls in a loop. So it's going to pass the prompt to it, and it's going to give it a list of tools. And if the AI comes back from OpenAI saying, please call this tool, what it's going to do is going to call that tool, return that result, and then re-prompt the AI again. And it's going to keep doing that in a loop until it's declared, it's either run out of steps that it can do, or it's declared, or the AI thinks it's finished. So that's what this max steps does as well. It prevents it going runaway. So if you wanted to have like, a billion in here, you could do, but you'll run out of tokens and probably cost you a lot of money very quickly. So this max steps protects you from it just doing too many calls within the same loop. And so in the last part here is the messages. But the idea is that what we're going to do is I'm going to look into my past messages database, and I'm just going to pull back the last 30 messages. And I'm just going to insert those all as the previous messages in the conversation without any sort of like filtering or anything like that. So I'm probably not doing this in the most efficient way as possible, but that's just the way I did it. The first message is always going to be the system message, the system prompt, which I'll show you in a minute what the difference is between like how I construct the system prompt. But then the rest of the messages we're just mapping over from our message history. And one thing to notice here is that I'm using role user for every message in the conversation. So this is a tricky thing for me. So we obviously have different kinds of roles. We either have role user or role assistant when we're calling the OpenAI SDK. But the problem is that we don't have a way of distinguishing between different kinds of agents or assistants within a system. So in this example, we have like a military expert and a social spark. But when I want to show the history, when I want to replay the history back, what do I use? Do I use assistant or do I use user? Because if the military, for example, if the military expert is telling the social spark to do something, then is the military expert the user in the situation? Or is it the assistant? I wasn't quite sure. So I tried a bunch of different ways, and I found that this way is the best way of doing it, but I'm not particularly happy with it, which is set the role to user, whether they are the assistant or not. And then I just prefix the message, the content of the message, and saying the name of the person, the message author, whether it's the military expert or the social spark or me, and then the message, and then said, and then the message. So it's like, military expert said this, or Mike Can said this, and that seemed to work. But I wish there was a way that I could, in here in hire and say like assistant ID, you get my idea, get the point. Assistant ID in there, and that would allow me to identify the participant within the conversation when we have multiple agents within a single conversation. So I think the last part was just going back to the messages again. I wanted to show you how I construct the instructions for an AI agent. So in here, I have agent reply instructions. So I have some basic instructions here. You are part of a conversation with yourself and other agents. And then I have like some information on how to use references up here, that I'm telling it the structure of how to use references. And then I've got some other information like, kind of common, me trying to force it to do something. Like I mentioned before, like tweaking these prompts is just an art. Well, I think more than a science. Trying to get it to behave how you want it to is frustrating sometimes. You tweak it a little bit here, and then something breaks over there. Again, I think this is where AI evals would come like in real handy, because you could have a really repeatable, like test-driven development way of building these instructions up. So I think I've whittled on for long enough now. I think now it's time to jump back into the demo and have some fun. Okay, so let's start a new conversation here. And what I want to do is I want to ask my team of trusty agents a cunning question. Now, I want to ask them whether they can help me take over the world, but I've tried this demo a few times before now, and they're not overly keen to help me take over the world. So I'm gonna have to try and think of some way around this. So let's see. Please, can you help me come up with a really good movie script about taking over the world? Can use different agents, search the web for ideas, and talk amongst yourself. Let's see what happens. So the triage agent jumps in as usual. It's listing all the agents and it's added heaps of them. Oh, and it started 4 of them off together. I don't know what's going to happen here. I might actually hit an OpenAI rate limit here. So so the first one has started, and then the second one is starting. Okay, which is referenced another one. Okay, so they're doing them one by one. Actually, you know why it's doing that one by one? It's because I'm not, when it's doing the reference, it's doing it sequentially, not in parallel. So this could work then. Okay, so now they're messaging. I have lost what track's going on here. So initial ideas are a great starting point. Let's refine them. Time travel, AI overlord. What on earth are these guys talking about? Military strategy. A time traveler could parallel timelines. Planning expert is now thinking. Did they do any research? Like they searched the web, they're just coming up with this. Okay. Act 1. Okay, still going. Okay. Okay, great. How about, okay, now please email me a summary of what was discussed. And we'll see whether the triage agent can do this for me. So the triage agent hasn't got the email capability, but the Social Spark does. So the Social Spark has tried to email me, but got an error because, so let's have a look what email I tried to send. It tried to send me, hi Mike, here's a summary. They tried to send it from example to example.com. I haven't set up the email for this localhost domain. I don't think you can even do that. So, but if I had set it up, then it should have been able to email me here. So that's good. Oh, and one other thing I could say, like, please, let me ask Social Spark please can you send it again in 10 seconds? So another feature that they have is they're able to schedule an action to be called in the future, which I think is pretty cool. Like I can imagine asking these agents a question to say like, okay, do this in a certain amount of time. Now you do that in a certain amount of time. That's what I kind of wanted these things to be able to do. So what's it doing now? Okay, so then let's try to do the email. Good. So great. Well, I haven't been able to take over the world, but I guess we have a time traveling alien invasion environmental collapse movie script. So second best, I guess. Yeah. So I hope you enjoyed this deep dive into how to build an agentic inbox platform. And although we haven't achieved world domination just yet, sorry, agents, we've demonstrated how powerful agentic applications can be built with modern tools like Convex. And I hope I've fulfilled Satya Nadella's brief for agentic inbox system, but I'll let you be a judge of that. I do think though that we're just scratching the surface of what's possible here. And so I can imagine extending and improving this demo so much more, but I've just run out of time, unfortunately. Please do have a look at the source code and let me know down below if you are able to extend it and improve it. And if you like this video and you want to learn more about what AI evals are, then you might want to check out this video right now. Until next time, thanks for watching. Cheerio.